Hi guys, welcome to DSP Virtual Lab. I'm Vishal from 3rd year EC department. Today we are going to see the experiment of spectral analysis using DFT, and the aim of the experiment is to find the magnitude and phase spectrum using DFT. Let's see some of the basics regarding DFT. Discrete Fourier transform is basically a computation tool used to evaluate Fourier transform on a digital computer. Unlike discrete time Fourier transform, which is defined for sequence of finite as well as infinite length, the DFT is defined for sequence of finite length only. As we know, the discrete time Fourier transform is continuous and periodic. The DFT is obtained by sampling one period of Fourier transform at a finite number of frequency points. If we use a digital computer to evaluate n frequency point over the interval 0 to 2 pi, the n frequency point would be located at omega is equal to 2 pi by n into k, where k represents the kth frequency path. This equally placed frequency points of discrete time Fourier transform represents the DFT and is denoted by x of k. So the formula of DFT can be obtained by replacing omega is equal to 2 pi by n into k in the formula of discrete time Fourier transform. So the formula of DFT is given by x of k is equal to summation of n is equal to 0 to n minus 1 x of n into e power minus j 2 pi k n divided by capital N, where k takes the value of 0 to n minus 1. In the same way, we can get the inverse DFT formula also. We can also write DFT and IDFT formula in terms of twiddle factor. The formula of twiddle factor in Wn is equal to e power minus j 2 pi divided by capital N. So we replace the exponential by Wn in the formula of DFT. We will get the DFT and IDFT formula in terms of twiddle factor. Now let's have a look at the program to get the magnitude and phase spectrum in MATLAB. The magnitude and phase plot is obtained in the following manner. The subplot is used so that the magnitude and phase plot is obtained in the same page and compared easily. The stem function is used due to the use of discrete value in our program, and ABS gives us the absolute value. The title of one graph is named as magnitude spectrum. The x-axis is labeled as discrete frequency and y-axis is labeled as amplitude. Similarly, we use subplot and stem function for phase plot, and the title of the graph is named as phase spectrum. The x-axis is named as discrete frequency, y-axis is named as phase angle. Similarly, we obtain the magnitude and phase plot in unwrapped manner, that is unfolding the spectrum. In here also we use the flow function to get the absolute value. The subplot and stem function is used so that the unfolded spectrum of both magnitude and phase is obtained in the same page and compared easily. The title of the graph is named as magnitude plot unfolded spectrum. The x-axis is named as discrete frequency, y-axis is named as amplitude. The subplot and stem again is used for phase spectrum unfolded. The title of the graph is named as phase plot unfolded spectrum. The x-axis is named as discrete frequency and y-axis is named as phase angle. Now let's have a look at the implementation of program in MATLAB. Let me first explain the three basic windows of MATLAB. The editor's window is used to write our program. The command window is used to give the input, execute our program and get the output. The workspace window is used to store the variables used in the program. First of all, we gave the basic command. Then we take the n is equal to input, the length of the sequence. The flow function is used to round off to the nearest integer. We take the rectangular signal function and use stem and subplot. The subplot is used for getting the graph in the same page, and stem is used due to the use of discrete values in our program. Then we take the DFT signal. To find the DFT signal, we take omega is equal to exponential e power minus j 2 pi divided by capital N. The small n and k values are given. Then both the n and k values are multiplied. Then w is equal to omega to the power nk, and we get the DFT signal by multiplying rectangular signal with the capital W. Then we obtain the magnitude and phase plot as explained before. The subplot and stem functions are used to get the graph in the same page. The title of the magnitude spectrum and phase spectrum are given, and x and y axis are labeled simultaneously. The unfolding the spectrum graph is also obtained. The y is equal to explore function is used to round off the value to the nearest integer, and the name of the graphs are given, and the axes are named simultaneously. Okay guys, now let's run the program and see what output we obtain after running this program. Now go to the editors menu and click on run. You can see in commanders window it will ask for the input, that is the length of the sequence. Let us give 63 and press enter. You can see the magnitude and phase spectrum is obtained in a single page along with the input signal which we have given. So to get the unfolded magnitude and phase spectrum, press enter. You can get the unfolded magnitude and phase spectrum in the same page. Now you can compare both the magnitude and phase spectrum in both the case unfolded and folded. Okay guys, the program was executed successfully. Thank you and have a wonderful day.